Some call it the main cause of death for life in the universe. Right or wrong, we should consider ourselves lucky that so far the most violent natural phenomenon of all has left our planet alone. If it one day does strike, better say goodbye. We don't stand a chance against the infamous gamma-ray bursts. It's like the lottery, really. Every day, somewhere in the universe, there's a huge explosion. Within seconds, an amount of energy sets free that equals the amount of energy the sun would emit in its entire lifetime. In fact, some of the blasts are bigger than the energy of all the stars combined. No, you just don't want to be around when such an explosion occurs. Strangely, the explosions are nearly invisible to the human eye. You would need gamma-ray vision to see them. We're talking gamma-ray bursts here. Cosmic super explosions that throw an awful amount of gamma and X radiation into the galaxy. It was only recently that scientists found out what gamma-ray bursts are. A GRB is usually what happens when a huge dying star is eaten up from within by a black hole. One moment you'll see a gigantic star, and then the next moment, it's gone, sucked up by a black hole. In those final moments, the black hole spews out a column of energy, almost at light speed. That's why gamma-ray bursts are often called the birth cries of black holes. A less friendly but more accurate term would be that GRBs are belching black holes after they've eaten a star. Gladly, until now, these super spectacular things only happened in distant galaxies billions of light years away. But then again, that could change. Heavy rotating stars like the one that caused gamma-ray bursts exists in our part of the galaxy too. At least one is about to go pop. Eta Carinae, a beautiful but dying star system in the southern constellation known as the Keyhole. Gladly, the burst won't hit us directly, since the axis of Eta Carinae is pointed away from us. But any day, we could stumble upon a dying star that is aimed at us. On a list of 20 phenomena that threaten life on Earth published by the popular science magazine Discover, gamma-ray bursters come second, right after asteroid impacts. As Arthur C. Clarke once pointed out, gamma explosions may be the reason why we don't notice much extraterrestrial life. Long before an ancient civilization would have come to the point of going out in a UFO to explore the galaxy, gamma-ray burst would have come and wiped it away. If a gamma-ray burst really does go flash somewhere in our cosmic neighborhood, the end of times would be really nasty. It would be like a Hiroshima bomb going off, on every place on Earth, at the same time. At a distance of something like 1,000 light years, the afterglow of the burst would light up as bright as the sun. Moments later, our planet would be bathed in a huge load of super-energetic gamma and X-rays. A fiery blast will set the atmosphere ablaze. Forests will burn, rivers and lakes will boil away, and the sides of the Earth facing the blast will be sterilized immediately. And you won't be safe on the other side of the planet either. A massive shockwave, much like the aftershock of a nuclear explosion, will sweep across the globe. A wall of fire will roast every living thing on Earth. Well, except a few fish, that is. The gamma-ray burst will reset evolution. Even a blast occurring farther out in the Milky Way won't be as good for our health. Okay, so the burst is too far away to fry us, but it can still mess up our atmosphere. The genetic gamma rays will grind up the molecules our atmosphere is made of into separate molecules of nitrogen and oxygen. These atoms will in turn mop up the ozone layer, leaving us exposed to the deadly UV radiation from the sun. And if that isn't enough to kill you, there will be the soot. High up in the atmosphere, the loose atoms will bind up into nitrogen dioxide, a brown, filthy gas that will blanket the sun. We'll have a massive nuclear winter and die a horrible climate disaster death. To make things worse, no one really knows how big the risks are. On the one hand, gamma-ray bursts that damage our world are likely to happen once every 10 million years on average. That would mean our planet has survived many, many bursts in the prehistoric past. On the other hand, it's hard to predict when the next GRB will hit us. Could be in a million years' time. Could be tomorrow.